Okay, so here's my project about the physics of volleyball. So the basics of volleyball are that there are 6 players on each side of the court at one time. Each side of the court is allowed 3 contacts on the ball, not including blocking, and no players can contact the net or cross under the net. The ball must land on or inside the lines of the court to be counted as in. Each play begins with a serve that must be received by the opposing team, and the main touches in the game are serving, passing, setting, hitting, and blocking. You can use kinematics to solve for the velocity, acceleration, position, and the time of the ball while it's in the air. And then to optimize each of your contacts, you want the ball right over the net, as far back or as close to the net, and you want the ball to have as much velocity as possible when you send it over to make it as difficult for the other team to receive. So since force equals mass times acceleration, you can use force to analyze like the way the ball moves. So the mass of the volleyball is about 0.27 kilograms. It has no horizontal acceleration because there's no forces acting on it. And there is the only vertical acceleration acting on the ball is gravity. And then the ball travels in the direction that the force is applied. And then for the player, the mass depends on the player, and the acceleration happens when the player runs, jumps, lands, swings, or dives. So when the player runs, they're accelerating. When they're jumping, they are jumping off the ground and then accelerating towards the ground. They're swinging their arms, accelerating. And then when they dive, they're accelerating towards the ground. You can use Newton's laws. So Newton's first law is inertia. And the ball, which says that the ball will not change motion unless another force acts on it. So that applies to every single contact in the game. So every time you pass it, hit it, block it, whatever, you're changing the ball's motion. So unless somebody contacts it, the ball's going to hit the ground, which is basically the entire game of volleyball. So the second law is force equals mass times acceleration, which I talked about before. And then the third law is that every action has an equal and opposite reaction. So you want to have the most possible action on the ball, so you want to give it the most force, so that the ball will have the same reaction. For torque happens when you apply force to an object at an angle that causes the object to pivot, which applies to the game in setting. So when you set, you have 2 hands on the ball and you're setting it up for another player to hit it. But in volleyball, each player can't contact the ball more than once. So if you contact it twice, then it's the other team's point. And if a setter applies torque to the ball, that means they've had 2 contacts because they caused the ball to pivot around one of their hands and then use their other hand to straighten out the motion of the ball. So you don't want torque when you set, and if you torque the ball, you lose the point. Kinetic energy. So there's kinetic energy that's translational, and there's kinetic energy that's rotational. So rotational energy is like the torque before, and then it also applies to serving. So when you do a topspin serve, you're jumping in the air and then hitting the ball with topspin down to the ground, which makes the ball rotate. So it has rotational kinetic energy and accelerates towards the ground much faster than a float serve, which is where the ball has no rotation. And it moves around in the air with friction with the air and then drops in an unpredictable way. So that one makes it really hard to receive. And you'd use a jump serve if you're just serving it super hard and it's really fast. So for the translational kinetic energy, the mass of the ball, again, is 0.27 kilograms. And then the horizontal velocity is constant, vertical acceleration is gravity. And then when the player contacts the ball, it's giving its work, so you can give the ball more energy. And then gravitational potential energy is when you send the ball up in the air, you're giving it more, like the delta Y is increasing, which means that it has more gravitational potential energy. And then that means that when the ball drops, it'll have more kinetic energy. And then the main energy conversions are between gravitational potential energy, rotational kinetic energy, and translational kinetic energy. So those apply in almost every single play. For impulse and momentum, this applies a lot when you're doing spiking. So if you have more impulse, that means you have more velocity. And to increase the amount of impulse that you have, you want to contact the ball for as long as possible. So you can't hold the ball because that's against the rules, but you can try and prolong the contact to increase that delta time, to increase your impulse. And since the object's change in momentum is its impulse, if you have more impulse, you have more momentum, and then you have more velocity because momentum is mass times velocity. That's it.